Okay, guys, welcome to class. It's nice to see you. Hold on, my camera is taking a second. There we go. It's nice to see you. I'm glad you're here. So what we're going to do today is a little different. Well, not so different, but we've done it before. But we're going to do a couple problems that I've identified as your guys' struggle points. I was looking at 9.2 and the attempts that had been turned in, and hydrates are giving people issues. And that's the nicest way I can say that. So I want to make sure that I personally go over it again to make sure that you understand exactly what I expect and what I need from you. And I'm gonna use the percent composition as a warm-up. Then we're gonna do some hydrate problems. And then we're gonna do the thing where I put you guys in breakout rooms. And then like you throw someone under the bus by making them team captain. And then they come back in and check your answers at different points. And we're gonna do that whole number. So you get to leave class today whenever you've demonstrated you understand how to do the formula thing. 9.2 is due tonight. So I'm putting 9.1 grades in now. I started that already. Some of you may already see some. 9.2 grades will go in tomorrow. So that is the idea. Are there any questions about anything before we start? Anything at all? Going once. Going twice. Oh, I see the chat blinking. 9.3 is a stoichiometry review. So I am not doing that today. I'm focusing on hydrates and molecular empirical formulas today because that's the grade for the day. I will be doing a stoichiometry review next class because QC 9.3, 9.4 are due next time. And I have both of those set up. The percent yield, which actually usually is one of the highest scoring parts because that's easier. It's what you get versus what you have. And the stoichiometry things we will be doing next class. Okay. So if you need to review stoichiometry, make sure you also know that you have those Zoom recordings folder in Canvas under the Zoom module at the very bottom where it says, were you absent from class or do you want to listen again with a question mark? That'll have a folder that's literally the entire year of chemistry, everything. And it's usually your class I record, so you can go watch me again. I do it for everybody. So yeah, if you need a review on stoichiometry, that is a great place to go. All right. I'm glad I asked questions. Starting up first, finding the percent composition of nitrogen in urea. Because we can make chemistry gross. Charles, where would I start with this problem? What is percent composition asking me for?
Well, you're looking for the percentage of, well, in this case, nitrogen of the urea. And to do that, you have to find the molar mass and then divide the mass of the nitrogen by the molar mass.
So find molar mass of nitrogen, but it has to be for all nitrogen in the sample, right? So
Yeah.
how many nitrogens do we have?
2.
So that's 2 times N, which off the periodic table is 2 times 14.007, which would give you 28.014 if my math is okay. All right. Then you said you need to find the molar mass of what? What's the second thing you said?
Urea.
Urea. So how would you do urea for us since he did nitrogen? Are you there? Are you there? Nope, not here. I'm talking to a ghost. Kira, how would I do that?
So you would keep the molar mass of nitrogen and then you would add that in later.
Okay.
And then the next thing I did was hydrogen.
Okay,
and
so how many hydrogens are there?
There's 4 hydrogens.
Yes, there are 2 nitrogens. There are 4 hydrogens. All right, what else?
And then there's 1 carbon and 1 oxygen.
And that gives you a total of what number when you're done?
8.
8 what?
Wait, the total mass or the total?
Yes, the total mass, the total mass.
Oh, the total mass. Okay, that's
yeah, sorry,
60.
I was not clear. That was me.
Okay.
What is it?
60 0.0556.
Okay, so we have the total, and these are from the periodic table, right? That's where we get those numbers from. So now that we have the mass of nitrogen and we have the mass of the total, Celine, what do we do next?
You have to divide the part of the nitrogen by the whole, so the 28.014 by the 60.0556, and then multiply by 100.
Yep. Step 3 is to divide them. So step 3 is to find the percent, which is always the part over the whole times 100%. So in this case, that is 2N over NH2CO NH2 times 100. And we already found those numbers. So we're using these and plugging them in. So we have 28.014 over 60.0556 times the 100. And that would give you, what did you say the percent was? I'm sorry, I missed it if you said it.
46.65.
All right, are there any questions on how we did this one? Any questions at all? Scale of 1 to 10 in the chat. Okay, you guys are giving me some high numbers. So the reason, because there's always a reason, right? The reason that I wanted to review percent composition first is because doing hydrates is the same as percentages and empirical formulas, but it is not empirical formulas, because empirical formulas are for empirical formulas and molecular formulas are for organic compounds that can bond and share their electrons differently. In ionic compounds, we are not sharing our electrons. We are transferring based on a numerical charge, and therefore only will ever bond one way. So what a hydrate is it's an ionic salt that has water in it. Then we remove the water and see what's left. So in case I did not make it explicitly clear, in a problem like this one, it says 150.00 gram sample of hydrated copper 2 nitrate is heated until all the water has evaporated. So what they're saying is they put this slushy salt in a beaker, and then they put heat to it, and they let all the water boil off until it was completely dry. And then once it's completely dry, then they weighed it to see what was there. So it's not that they're bonding a different way, it's that we're taking water that's there and removing it so we can find the mass of just the salt. So whatever boiled off has to be the mass of the water, because conservation of mass. So that is how we attack this problem. So Milan, what do we do with every problem first?
We have to highlight or underline.
Yeah, we have to, well, highlight or important information for any class, right? So how would you do that?
So we would first underline like the 150 gram sample of
Yep.
hydrated copper.
So that is the total mass, the mass of the copper, the mass of the water. What is that?
Then the mass of 116.44 grams.
Yep, so let me do this. Total mass is equal to 150.00 grams. Then you said that the mass of the dry compound is 116.44. So how would I write the dry compound? How do I write this?
Would that be Cu or
So
no?
Cu, so copper is Cu. What's the charge of copper based on this?
Oh, it's +2.
Right, because remember that when there's a Roman numeral, it means there's multiple forms of oxidation states. And this is telling us which one. So we need the 2+ oxidation state, not the 3 or the 4 or whatever, right? Nitrate, where can I find nitrate?
That would be N3, and so -3.
It's what? I'm sorry, you cut out.
It's N negative -3.
That is nitrogen. This is nitrate.
Oh,
Nitrate. So it's a polyatomic ion. And what handy dandy thing do you have that you can look in for nitrate?
Oh, my reference packet.
Your reference packet. I need like a bell or something weird that I get like ding every time you say reference packet. I'm like, reference packet. Like I just need to be like super obnoxious. I need to figure that out. So if you know, if you're really good at being obnoxious, you can help me figure that out. I want to be super obnoxious whenever you say reference packet. But reference packet. So what is nitrate in your reference packet?
It's NO3 minus.
It is NO3 minus. So how many nitrates do I need to balance my copper?
2.
2. I need 2 of these, right? So I'm going to end up with CuNO3 2. Awesome. Good job, Milan. Thank you for letting me torture you for such a long amount of time. Renee, how do I find the mass of the other part? The salt is one thing. What is the other thing?
The water. So you would take the 150 gram sample and subtract the anhydrous compound, which is 116.44.
And when you do that, what do you get for your number?
33.56.
Love it. 33.56 grams of water. And I love that you said anhydrous correctly. Anhydrous is just without hydrate or without water. So that's why it's dry. Awesome. Adhish, I have all my masses. Now I can do this like a percent composition problem. So how do I start? Or an empirical formula problem, I should say.
So you start with the anhydrous and the mass hydrate, the mass of the hydrate.
Yeah, one, we're going to write our masses, right? Right, masses. That was number 1. So for copper nitrate, copper 2 nitrate, we said the mass was 116.44 grams, and that for water, the mass was 33.56 grams. Awesome. What do I do next? Mahim.
Sorry, I was solving, so I'm kind of lost where we are.
Okay, we wrote down the masses of each of our compounds, and this is the beginning of an empirical formula problem, kind of like percent composition, right? So we have each mass. What's our next step? Once we get the masses, what do we have to get it into?
So we divide each one by its molar mass. So 116.44 divided by 187.554 and 33.56 divided by 18.02.
Love it. Yes. So she found these molar masses by adding these up from the periodic table, just in case you weren't aware, just as a reminder. So that gives us the number of moles. So when you do that, what do you get for moles of copper?
I got 0.62.
0.62-ish, right? We technically don't round until the end, but when we're doing these, we know we're going to end up with a ratio anyway, so it's all right. What about water?
1.86-ish. Wait, no.
Yep,
Yeah.
that's fine. Ish. We can do the ish like that. So from this point, what do I do now, Lucas?
Do you divide it?
Yep, I divide by what?
You divide it by the smallest one, which is
Love it.
0.6.
Yes, and when I do that, this one comes out to be 1. And this one comes out to be 3. Okay. So last but not least, Dia, what does this formula look like?
It would be the copper 2 nitrate and then 3 waters. So that would be trihydrate.
Perfect. You got all the way there. Yes, we do our little weird multiplication dot, 3H2O, and this is copper 2 nitrate trihydrate. I only capitalized it so it stuck out. The only thing that changes with hydrate names is how many. If there had been 4, it would be different. 5, it would be different. It'd be pentahydrate, whatever. So scale of 1 to 10, how do we feel now? Okay. I want you guys to try to solve this one. I'm going to give you around 8 minutes to get this one done. and you're going to put your answer in the chat. And then once you do that, I'll tell you if you're right or wrong. I'm going to run to the bathroom very quickly while you guys are doing that. So I'll be back in like just a couple minutes. It's right outside my door. But I'm going to mute myself so that way the room isn't making sounds. But try to solve this. Give me the answer and I'll verify. You're going to have 8 minutes. So basically till 11:56. Okay. All right. Try this problem. Do the thing. Guys have just a few more minutes to try your attempt. A lot of you guys are getting it. You guys want one more minute? Okay, I'm gonna quickly run through this one. Most of you got it correct. Some of you struggled with a little bit of it. So I want to do the whole thing really quick. And once I do that, then I'll put you guys in your groups, okay? So the first part of this problem is identifying that we have a total mass of 325 grams. Okay, and that we have the mass of just the salt, which is magnesium sulfate, which is MgSO4 because it's Mg2 plus and SO4 2 minus, is 158.69 grams. Once we do that, we can subtract it, get just the water alone. And if you get just the water alone, you should get 166.31 grams. So that's how we're starting. So step one is to write those masses with the compounds. So we know that magnesium sulfate is 158.69 grams, and we know that water is 166.31 grams, okay? The second step would have been to divide by molar mass for each one. So when we divide by the molar mass of each one, magnesium sulfate, if you did the molar mass correctly, is 120.36 grams, and that's just adding up each one of these from the periodic table. For water, it's still the 18.02 grams that we've been using. So when you do that, you should have gotten 1.3185-ish, and you should have gotten 9.2292-ish for the number of moles, okay? Because that's what we're doing, is converting to moles. This is grams per mole. This is grams per mole. All right. After that, you divide by the smallest. So when you divide by the smallest, that is the 1.3185, 1.3185. And if you do that correctly, you should have 1 for magnesium and 7 for water. So the way that would look is that you have 1 magnesium for every 7 waters. So you would have magnesium sulfate dot 7H2O, which is magnesium sulfate heptahydrate. All right, give me a scale of 1 to 10 in the chat of how you're feeling. 1 to 10 in the chat. After saying it, a couple of you were close but slightly off. Good. Are there any questions on this problem? All right. So now, guys, we're at that time of the day where we're going to do a group activity. So let me show you what that activity looks like first. So this is what we're going to be doing. So a couple notes. You can have examples of how to work each thing here. This is all the options that you have. For this slide, the number of people that are misdoing it is a lot, not because they're getting it wrong necessarily, but the type or the title goes up here. The words ratio or exact go in the blanks. And down here, you actually count the atoms and give me the empirical and molecular formula, the actual formula. It's not a label. Like I want you to actually put the letters in the numbers, okay? Here we're dragging, here we're dragging. Notice that there's this stop sign randomly throughout the guy. So it's after each section. So when you see this stop sign, you stop, take your team leader that you have nominated, and they come back to the main room and share their screen with me for me to be able to check your work. Once I give them the go ahead, they will come back and then you will move to the next section. And then they will stop and then you will come back and I will check and then we'll go to the next section. So that's how this is going to work. Okay. So what do you think you need to do first once you get in the breakout room? Where did my wheel go? What do you got to do first? Jessica.
I'm sorry, can you repeat the question?
Yeah, what do you have to do first when you get in your breakout room? You're going to have this sheet. I'm going to give you the link in the chat. What do you guys have to do?
Find a team leader.
Find a team leader, throw someone under the bus, right? Tire marks on the back. So they're the ones that are going to be coming back and forth. Only one person is going to be coming back and forth. When do you get to leave class? Akshar, when do you get to leave class?
When the team leader checks everything.
Yep, when everything's checked and I say you're dismissed. So some people have gotten out within like 5-10 minutes. Other people have stayed for a half hour. And what that does is it allows me to help the people who need help. And if you know what you're doing, you can get out of here, right? So it's hopefully helpful to everybody. So this link I'm going to put in the chat. Hold on. Again, this is not in Canvas. The reason I'm not putting it in Canvas because last time I know that I told you guys you have to do all activities to retake a test. And a lot of people thought that included these ones. And then it said don't submit it. And there was no way to submit it. And it was a nightmare because I didn't want you guys to submit it. It was for your notes. So it's in the chat now. That's how you're getting it. It's right there. You click on it, make sure it opens. I'm going to make your breakout room slightly bigger. So that way you have lots of people to talk to and less people going back and forth. And your rooms are open. Happy calculating.